Good day, Grade 7. Today's discussion will be about Science 7, Quarter 4, Module 8, Eclipse. The content of this video is taken from the self-learning modules produced by the Learning Resource Management and Development System of the Schools Division of Bulacan. Objectives: explain how solar and lunar eclipses occur using models. At the end of this module, you are expected to 1. Define eclipse, 2. Differentiate solar eclipse from lunar eclipse, and 3. Explain how solar and lunar eclipses occur using models. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 2 to 4 of Quarter 4, Module 8. After discussing the motions of the Earth, let us now focus on the motions of another celestial object, the Moon. The Moon is the Earth's only natural satellite and the fifth largest moon in the solar system. The Moon's presence helps stabilize our planet's wobble and moderate our climate. The Moon's distance from Earth is about 385,000 kilometers. The Moon has a very thin atmosphere called an exosphere. You have seen that the shape of the moon appears to change from night to night. You have learned in the previous grades that the changing phases of the moon are due to the revolution of the moon. The movement of the moon also produces other phenomena. What's in? Do you know how shadows are formed? How about eclipses? Do you know why they occur? Do you think that shadows and eclipses are related in any way? How are shadows formed and how do shadows affect the surroundings? Number 1. When a light source is blocked by an object, a shadow of that object is cast. The shadow will darken the object on which it falls. Number 2, the distance of the object from the light source affects the size of its shadow. When an object is closer to the light source, its shadow will appear big. But when it is farther from the light source, its shadow is smaller. The occurrence of shadows is an ordinary phenomenon that you experience every day. Shadows can be seen anywhere. Sometimes the shadow appears bigger than the original object, other times smaller. Let us take a look at the following pictures. When a light source is blocked by an object, a shadow of that object is cast. So in this first picture, our light source is the sun, and the object that blocked the light coming from the sun is this person. Now, the shadow of this person will darken the object on which it falls, and the shadow falls on the ground. Next. In this picture, our light source is the flashlight and the object is this can. So the distance of the object from the light source affects the size of its shadow. When the object is closer to the light source, as in this picture, its shadow will appear big. But when the object is farther from the light source, then its shadow will be smaller. Next, the occurrence of shadow is an ordinary phenomenon. So we experience shadows every day. How about in outer space? Are shadows formed there too? How can you tell when you are here on Earth? Before we proceed discussing the scientific explanation for the occurrence of eclipses, let us read some beliefs regarding this natural phenomena. What's new? Let us read. According to the Visayan myth, there is an eclipse because there is a part serpent, part dragon creature called a Bakunawa that is trying to eat the sun and the moon coming from the seas. In order for it not to be successful in eating the sun and the moon, the people have to shout in order to distract it and make it spit out the sun and the moon so that it may return to its original place. The Bakunawa is a serpent-like dragon in Philippine mythology. It is believed to be the cause of eclipses, earthquakes, rains, and wind. It was generally believed to be a sea serpent, but are also variously believed to inhabit either the sky or the underworld. Here is another superstitious belief regarding eclipses. Pregnant mothers should stay indoors during an eclipse. During an eclipse, many have advised their pregnant friends and relatives not to go out during the duration of the natural phenomena. Although no scientific proof has been established connecting pregnancy and eclipse, according to beliefs, the unborn child could develop deformity if the expectant mother goes outside. If pregnant women go out of the house during a solar eclipse, or if the sun's rays during the event of eclipse fall on a pregnant woman's body, it will cause facial birth defects. This belief has been shared and passed on for generations. In ancient China and Egypt, the high priest taught the people that when an eclipse came, an evil dragon spirit was eating up the sun and it would disappear forever unless prayers were said and offerings were made. Other magicians and sorcerers, knowing that an eclipse was due, threatened to remove the sun from the sky unless certain of their demands were met. When the eclipse began, the people were convinced that the magician was making good his threat. After they gave him what he wanted, he would promise to make the sun reappear in a few hours, which of course it was going to do in any case. If you are ever lucky enough to see a total solar eclipse, you will discover that it is an awe-inspiring sight. As the moon approaches the sun, the skies begin to darken as they do at regular twilight. On the farms, chickens go to roost thinking that it's nightfall. When the moon completely obscures the sun's flaming ball, the sky becomes almost as dark as a moonless night. Then, in a few minutes, the moon passes across the sun and disappears from view, and the day becomes bright again. In the earlier grades, you learned about the members of the solar system. You know that the sun gives off light. As the different members of the solar system move around the sun, they block the light from the sun and form shadows. What this means is that planets have shadows, and even their moons have shadows too. But we cannot see the shadows that they form because we are far from them. The only shadows that we can observe are the shadows of the moon and earth. When shadows are formed on astronomical objects, a darkening effect is observed. This phenomenon is called an eclipse. An eclipse occurs when one heavenly body, such as a moon or planet, moves into the shadow of another heavenly body. Look at figure 1. In the drawing, there are two moons. Of course, you know that we only have one moon. The figure is just showing you the moon at two different locations as it goes around the earth. The figure shows where the shadows of the moon and earth are as viewed in space. But here on earth, you cannot observe the shadows. Why? Look at the shadow of the moon in positions A and B. In position A, the moon is too high. Its shadow does not fall on Earth. In position B, the moon is too low. The shadow of the Earth does not fall on the moon. The shadows of the Earth and the moon are cast in space. So, when can we observe the shadows? In what positions can we see the shadows? Let us look at another arrangement. In figure 2, the Earth has moved along its orbit, taking the moon along. The moon is shown in two different locations once more. Note that at these positions, the moon is neither too high nor too low. In fact, the moon is in a straight line between the sun and the earth. The three objects are perfectly aligned. At position A, where does the shadow of the moon fall? As you can see, the shadow of the moon now falls on Earth. When you are within the shadow, you will experience a solar eclipse. A solar eclipse occurs when the moon comes directly between the sun and Earth. Sometimes, when the moon orbits the Earth, the moon moves between the sun and Earth. When this happens, the moon blocks the light of the sun from reaching Earth. This causes an eclipse of the sun or a solar eclipse. During a solar eclipse, the moon casts a shadow onto Earth. Solar eclipses happen only during a new moon, when the lunar orb moves between the sun and Earth. Let us look at the sun, moon, and earth in figure 3. Look at the tip of the shadow of the moon as it falls on earth. Is the entire shadow of the moon completely dark? Do you notice the unequal shading of the shadow? It has a gray outer part and a darker inner part. This gray outer region is the penumbra, while the darker inner region is the umbra. During a solar eclipse, the moon casts two shadows on Earth. The umbra gets smaller as it reaches Earth. It is the dark center of the moon's shadow. The penumbra gets larger as it reaches Earth. If you are standing within the umbra of the moon's shadow, you will see the sun disappear from your view. The surroundings appear like it is early evening. In this case, you are witnessing a total solar eclipse. A total solar eclipse is visible from a small area on Earth. The people who see the total eclipse are in the center of the moon's shadow when it hits Earth. The sky becomes very dark as if it were night. For a total eclipse to occur, the sun, moon, and Earth must be in a direct line. In comparison, if you are in the penumbra, you will see the sun partially covered by the moon. There are no dramatic changes in the surroundings. There is no noticeable dimming of sunlight. In this case, you are observing a partial solar eclipse. So in this picture, if you are within the umbra of the moon's shadow, then on Earth, you will be seeing a total solar eclipse. But if you are in the penumbra of the moon shadow, then you will see a partial solar eclipse. Partial solar eclipses happen when the sun, moon, and earth are not exactly aligned. The sun appears to have a dark shadow on a small part of its surface. Let us go back to figure 2. Look at the moon in position B. Do you notice that at this position, the moon is also aligned with the sun and earth? So in position B, the moon, earth, and sun are in a straight line. At this position, a different type of eclipse occurs. This time, the moon is in the shadow of the earth. In this case, you will observe a lunar eclipse. A lunar eclipse occurs when the moon is directly on the opposite side of the earth as the sun. The moon moves in orbit around Earth. At the same time, the earth orbits the sun. Sometimes, Earth moves between sun and the moon. When this happens, Earth blocks the light from the sun that normally is reflected by the moon. This sunlight is what causes the moon to shine. Instead of light hitting the moon's surface, Earth's shadow falls on the moon. This is an eclipse of the moon or a lunar eclipse. A lunar eclipse can occur only when the moon is full. In a lunar eclipse, the shadow of the Earth also darkens the moon. Focus your attention on the shadow of the Earth. The shadow is wider than that of the moon. It also has an umbra and a penumbra. Which part of the Earth's shadow falls on the moon? Is the moon always found within the umbra? The appearance of the moon is dependent on its location in the Earth's shadow. When the entire moon is within the umbra, it will look totally dark. At this time, you will observe a total lunar eclipse. So when the moon is within the umbra of the Earth's shadow, then you will observe a total lunar eclipse. But when the moon passes only through a part of the umbra, a partial lunar eclipse will be observed. A part of the moon will look dark while the rest will be lighter. So if the moon goes only through a part of the umbra and some parts of the penumbra, then at this point, you will be able to witness a partial lunar eclipse. A total lunar eclipse occurs when the moon and the sun are on exact opposite sides of Earth. Although the moon is in Earth's shadow, some sunlight reaches the moon. The sunlight passes through Earth's atmosphere, which filters out most of the blue light. This makes the moon appear red to people on Earth. A partial lunar eclipse happens when part of the moon enters Earth's shadow. In a partial eclipse, Earth's shadow appears very dark on the side of the moon facing Earth. What people see from Earth during a partial lunar eclipse depends on how the sun, Earth, and moon align. It takes about 1 month for the moon to complete its trip around the Earth. If that is the case, then we should be observing monthly eclipses. In reality, eclipses do not occur every month. There are only about 3 solar eclipses and 3 lunar eclipses in a year. What could be the reason for this? The answer lies in the orbit of the moon. Look at the orbit of the Earth and the moon in figures 1 and 2. Do their orbits have the same orientations? As you can see, the moon's orbit is slightly inclined. The orbit is tilted by 5 degrees from the plane of orbit of Earth. As the moon moves around the Earth, it is sometimes higher or lower than the Earth. In these situations, the shadow of the moon does not hit the surface of the Earth, thus no eclipses will occur. Eclipses only happen when the moon aligns with the sun and Earth. So in figure number 1, we could see that in position A, the moon is higher than the Earth. In position B, the moon is lower than the Earth. During these two positions, no eclipses will occur. Eclipses will only occur when the sun, moon, and Earth are aligned with each other. They must form a direct line in order for eclipses to take place. Which among the beliefs that you have read in What's New do you consider true? Do all the beliefs you have read have scientific basis? Are the explanations of the occurrences of eclipses related to these beliefs? Are there any proofs that tell you they are true? In science, explanations are supported with evidence. Beliefs related to eclipses are passed on by adults to young children, but until now, no proof has been offered to show that they are true. However, there are beliefs that have scientific basis. For example, it is bad to look directly at the sun during a solar eclipse. Even if a solar eclipse happens only for a few minutes, never look directly at the sun. You must use proper safety equipment to look at any type of solar eclipse. A lunar eclipse usually lasts for a few hours. It is safe to look at a lunar eclipse. It is bad to look directly at the sun during a solar eclipse. Doing so will damage your eyes. This is true. Even if only a thin crescent of the sun is left uncovered by the moon, it will still be too bright for you to observe. In fact, it is 10,000 times brighter than the full moon, and it will certainly harm your retina. So even if you observe a solar eclipse, be ready with a solar filter or welder's goggles to protect your eyes. What's more, Independent Activity 1, Activity Eclipses. Objective, to make a model of a solar eclipse and lunar eclipse. Materials needed, 2 drinking glasses, 2 plastic balls of different sizes, flashlight or pen light. Safety notes, be careful in handling glasses and in using flashlight or pen light. Work with adult supervision. Procedures: number 1, get a medium-sized ball to represent the Earth and a small ball to represent the Moon. Place it on top of the 2 drinking glasses. Use a flashlight to represent the sun and to light up your model. Note, make sure that the glasses are aligned and far from each other. Guide questions. Number 1, what did you observe when the moon is between the Earth and the sun? 2, what did you observe when the Earth is between the sun and the moon? 3, what is formed when the moon, Earth, and sun are aligned? And 4, what is an eclipse? What is the difference between a solar eclipse and a lunar eclipse? Independent Assessment 1. Identification. Identify what is being described for each of the following statements. Choose your answer from the choices below. So your choices are lunar eclipse, partial lunar eclipse, penumbra, solar eclipse, and umbra. Independent Activity 2. Illustration. Draw the position of the moon, the sun, and the earth during a solar eclipse and lunar eclipse. The score will be based on the following criteria. The appearance of the drawing looks similar to what was learned. It is properly labeled. The size of the drawing is big enough to see all the details. So, if your work is similar to this, then you will get a perfect score. Independent Assessment 2. In your answer sheet, write the difference between letter A, solar eclipse and lunar eclipse. B, umbra and penumbra. C, partial solar eclipse and total solar eclipse. D, partial lunar eclipse and total lunar eclipse. Your score will be rated based on the following criteria. Independent Activity 3, Essay. Answer the given question. What is the importance of eclipse? You will be given a score based on the following criteria. For you to be able to get a perfect score, the idea must be clearly stated and logically organized, research information and personal ideas were cited, and the written work has no error. Independent Assessment 3. Complete the following statement. What I have learned. Directions. Complete the following. Metacognition for stating knowledge. My chosen word is, I know that I know. First I know. In addition I know. Finally I know. Solar eclipse. A solar eclipse occurs when the moon is between the sun and the earth. During a solar eclipse, the moon blocks the light from the sun. A shadow is cast on Earth. The umbra is the darker inner shadow of the moon. The penumbra is the lighter outer shadow of the moon. If you are standing in the umbra of the moon, then you will be witnessing a total solar eclipse. If you are standing within the penumbra of the moon, then you will be seeing a partial solar eclipse. Lunar eclipse. A lunar eclipse occurs when the Earth is between the sun and the moon. The Earth casts a shadow on the moon. If the moon is within the umbra of the Earth, then we will witness a total lunar eclipse. If the moon is within a part of the umbra only, then we will witness a partial lunar eclipse. What I can do. A solar eclipse does not frequently happen. As a grade 7 student, what safety precautions can you give in order to protect your eyes while observing a partial solar eclipse? Your score will be based on the following criteria: content, 10 points; understanding, application, 10 points, for a total of 20 points. Assessment: write the word true if the statement is correct and false if it is not. See page 13 of Quarter 4, Module 8. Additional activity, performance task number 4.8, web map. Write down words related to eclipse. Science 7, Quarter 4, Module 8, Eclipse. Answer the following on your answer sheet. What I know, what's more, independent activities 1, 2, 3, independent assessments 1, 2, 3, what I have learned, what I can do, assessment, and additional activities. The additional activity will be your performance task number 4.8. Upload your answer sheets in PDF format in your Google Drive folder. The path is Science 7, Quarter 4, Module 8, or send them in JPEG format to my messenger. Thank you for attending our Science 7 online class. God bless you all.